How does the internet work? The switching techniques specify how information units are transferred over the network. There are mainly two types of switching techniques, the circuit switching and the packet switching. The circuit switching consists of a dedicated circuit that is established for each call. And this is mainly connection-oriented. It means that before performing a call, there is a circuit that is established between the source and destination nodes. In the packet switching instead, the data is broken into blocks of appropriate length and sent over the network. In this case, it's generally connectionless, so in this case, we don't need to establish a circuit before. The circuit switching is a type of switching that is typical of telephone systems, of old telephone networks, in which the communication resources are reserved for the entire duration of the call. But let's make an example. Let's say that we want to interconnect these two phones on a telephone network. At the very beginning, the source starts to make the call. Then the network finds a circuit, an available circuit over the network. Then it opens the circuit, and only after this step, the final destination phone can ring. After ringing, then we can have the operation of the call. If we want to look inside what are the network resources that are involved in circuit switching, we can say that the network resources are divided into slices. Each slice is allocated to a circuit or to a continuous information flow. These resources remain inactive if not used. So in this case, we don't have sharing of resources, and this is an important feature in our networks. And the network resources can be done of multiple types. So, for instance, can be based on frequency division, can be based on time division or wavelength division, for instance, or also space division. So we can dedicate specific physical circuit to establish our calls. Now, if we look inside on a node, so if we want to model the circuit switching node, we can see that the capacity at the input channels is equal to the capacity of the output channel in terms of bit per second. So in this case, we don't need to memorize information along the circuit once it has been established, because the input is directly connected to the output. Different with the packet switching instead, what we divide is not the resource of the network, but we divide the information into chunks. So at the end, the connections are not divided into slices, such as in the circuit switching. So the information then is in form of a packet, and the packet is formed by the header and the payload. Into the header, we can there are informations that can be used to reach the destination. Instead, the payload carries the user data. Well, why do we split the data flow into packets? So first of all, packets from all users can share the same network resources. So here we don't have to slice the network resources, so we can use them on it. We can use the entire capacity of the network. Each packet uses the channel completely for a certain period of time. And in this way, the resources are used only as needed, so when they are needed. So let's make an example also in this case. So let's say that host C wants to send a packet towards host A. This packet has a header and a data payload. This packet, when it is reached by the first network node that we call router, looks inside a routing table. The routing table is a very simple table that has two fields, the destination address and the next hop. So it looks inside the header, it reads the destination address, and then it forwards the packet towards the next hop, that is router 2. When the packet is reached by router 2, it also looks inside a routing table, and then it can check, it can see that it is directly connected to the final host, and then it sends the packet to the final host. Now, this is in general how a packet is forwarded into a packet switching network, but then we will see into specific details how the router performs these operations. So also in this case, if we want to see a node model more into the details, we can see that the capacity of the link is arbitrary, and there may be timing conflicts for transmissions. And this means that in this case, we need to store the packet into a queue. So we have a pre-processing that we call store and forward. So we need to store the entire packet before to transmit on the outgoing link. And then we have the statistical multiplexing feature, because the packet then has to be queued and it has to wait for the other packets before to be sent. So then at the end, which one is better? So the answer is it depends. It depends on the network technology. However, the packet switching is the internet choice. But what do we pay for this increased efficiency? Well, we have the queue problem. So we might have packet loss due to limited buffer size, and also delay that cannot be computed a priori. Also, in this case, in the packet switching case, we might have a further division of technology. So we can have a packet switching datagram and a packet switching virtual circuit. In the datagram case, the choice of the out port is made based on the destination address only. So packets of the same flow are forwarded independently. However, with the virtual circuit, we try to mimic the behavior of the virtual switching. So the nodes route packets based on a label. So the virtual circuit is established in a setup phase, and packets follow the same path because they are routed based on a label and not anymore on the destination address.